Welcome everyone. Thank you very much for joining our joint webinar with Predict Wind, leveraging open ocean weather data to improve sailing conditions. So before we get started, just want to introduce our speakers today. So joining us from Predict Wind, we have Jack Catsley, who is the head meteorologist, and Nick Olson, who is head of business development and marketing. And then on our side at Spire, we have Keenan Fryer, who is a applied meteorologist, and myself, Emily Cooper, digital marketing. So just to give you an idea of what you can expect from today's session, we'll kick off with a brief overview on why it's important to have accurate weather forecasts. Why it's important to have accurate weather forecasts for the maritime industry, and then we'll give you a brief explanation of who we are, Spire Global and Spire Maritime, and then I'll hand over to Keenan, who will go over the challenges of collecting data in open ocean and how radio occultation can potentially solve this problem. Then Jack will take over to talk about how at Predict Wind they conducted a data validation report to assess the value of Spire's weather data in open ocean, specifically wind and direction. And then Nick will take over to give you a demo of the Predict Wind app and show you how they use various weather models for weather routing. Then we'll have a little bit of time at the end for Q&A. So if you have questions throughout the session, please feel free to use the question tool on your go-to webinar control panel, and we'll address them at the end. So just before we get started, I'd like to launch a quick poll. So it should show up on your screen right now. There we go. If you could just take a few seconds to answer, and then we'll move on. Can everyone see their poll? It's just on the screen there. I'll just wait a few more seconds. Some people are still voting. I'll just wait a little bit longer. Sorry, everyone. Okay, that's great. Thank you very much, everyone. I'm just going to close the poll now. Great. So, why is it important to have accurate weather for the maritime industry? Obviously, the most obvious would definitely be the time and fuel management, being able to adapt to the conditions out at sea, the weather conditions out at sea, allows us to make data-driven decisions to optimize not only the time that we take on a voyage, but also how we manage the fuel. And this is directly linked to emission savings and complying to the IMO 2020 sulfur cap. And then one of the most important would also be the crew and cargo safety. Adverse weather poses a real risk to crew and cargo at port and in open ocean, and having a better, more accurate understanding of the weather can definitely help to mitigate those risks. So vessel performance, we hear a lot about vessel performance when we talk about using weather forecasts to optimize your shipping, both vessel and voyage performance. So obviously weather forecasts can help with cost efficiency, the fuel consumption. So IMO estimates that weather routing can save 3% of fuel consumption in shipping, and that can go up to 10% for container shipping. And then this obviously brings us to developing more accurate and more optimized e-navigation or ship routing. So using weather as a key factor when deciding what the best distance is, what the best route is to get from one distance to another. Operations as well, weather forecast can optimize shipping operations, whether that be in compliance when it comes to respecting a charter party warranty, or even incidents, investigations, logistics. So not just when it comes to the fuel and time, but any kind of disruptions ripple through the supply chain. And weather can help mitigate those logistic disruptions. Maintenance as well, understanding when to conduct maintenance on a ship, depending on what kind of weather it's been through, and crew and cargo safety, as we've already discussed. Weather forecasts. So within the weather forecast, we have multiple different variables that are very specific to the maritime industry, and very interesting to be able to monitor the vessel performance, the operations, and the emission savings. So this is our key variables that really do influence these things. But Spire Weather actually has more than 50 different variables that are specific to the maritime industry to offer. So about Spire Global, so we are a global and data analytics company. We build and launch our own satellites. This gives us big control over how we are able to innovate and iterate faster on our data collection. The more satellites we launch, the more volume we're able to collect. And then we are also able to iterate fast on our both software and hardware, allowing us to improve data processing, apply machine learning, both on board the spacecraft and also on the ground. And that allows us to continue to improve and evolve our products. So Spire Maritime is a division of Spire Global, and we provide location and weather data to the maritime industry. We like to aggregate as much data as possible to offer an all-in-one solution, which obviously includes weather, which we'll talk a little bit more about in a minute. And our satellites are able to cover the Earth 24/7, and our 3 different types of AIS data are able to provide unprecedented coverage in terms of volumes of positions. And we do all of this through easy to use APIs because we want our clean and our smart data to be easily accessible to all. So this is our mission. Our mission is to acquire data, aggregate it, and to provide analytical services with that data in order to help our customers save money, save time, improve reliability, and improve safety. Right, so before I hand over to my colleague Keenan, I would like to run one more poll. So I'm just going to select it now. And again, same thing as before, if you wouldn't mind voting. Thank you very much. Okay, that's great. I'm just going to close the poll now. Thank you very much, everyone, and hand over to Keenan.
Thanks, Emily. Okay, let's see. Oh, okay. So with observations over the ocean, there's a couple of problems. High costs in installation and maintaining those observations, and that's due to the fact that the ocean's a pretty brutal place and that seawater is corrosive. So that, combined with large distances that you're going to need to travel to maintain those installations, and the multiple man hours that it's going to take to do that maintenance after that travel, presents quite a few challenges for gaining observations over the ocean. Okay, so at the surface, there are a number of existing or traditional observation data sets. So the first is the set of meteorological variable instrumentation sets at in the on buoys over the Pacific, over the entire world. So here on the left-hand side is a map of the buoy locations that have meteorological sensors in the Pacific Ocean. And so you can see this leaves a huge area of the ocean unobserved. And that's because buoys are going to generally be relegated to coastal environments due to the fact that they are moored, so the ocean can only be so deep. In addition to the fact that to maintain those observations, you're going to need to travel to them. So that's a big part. And then so that data set is complemented by the large data set that we get from maritime traffic from ships of opportunity, which are basically just maritime vessels that are fitted with sensors. So they're great, but they do generally retrace well-traveled routes, and they have, and to some degree they'll avoid bad weather for good reason. But that does leave us with an absence of observations in sometimes the most important area to have those observations. And so on the right-hand side, I'm just showing a plot of 24 hours of maritime traffic from satellite AIS data. Jack, did you want to add anything about surface observations?
Yeah, I was just noticing that the buoy one there on the left it's just keep that in mind when we do the validation study, because we compare it against buoys, and you can see the distribution of buoys are primarily on coastal regions, and especially in North America and in the tropical Pacific. So just keep that in mind when I show the validation results, that we're not sampling the full ocean necessarily, because we are comparing against buoys, which are fairly limited in, as you said, location.
Yep. Yeah, and all those red dots are actually stations where they're no longer collecting current observations. They've gone down for one reason or another. Let's see. Okay, so the problems at the surface are one thing, but they get a lot worse when you go to collect observations above the ocean surface through a larger depth of the atmosphere. And so here shown on the right is a plot of all the upper air locations across the whole world. And so at these sites, twice a day, an expert will launch a radiosonde. So a radiosonde is just like a sensor package attached to a high altitude balloon. And again, that has to be manually launched by an expert. And so the key thing that you'll notice in that plot is that there are no upper air sites over the ocean for good reason. But so that does leave us with huge gaps in the vertical ability, the ability to sample the atmosphere vertically. Those observations are complemented by aircraft traffic, which is often fitted with meteorological sensors. But the issue with those is that over the ocean, predominantly, they're going to be at cruising altitude. So that leaves much of the depth of the atmosphere unsampled. And so finally, we do have satellite microwave sounders, which do record temperature profiles through the atmosphere. But they themselves are going to suffer from issues of coarse resolution in the horizontal, and even maybe more importantly, coarse vertical resolution. Again, Jack, did you want to add anything?
No, I mean, one other thing that you don't cover there is, at least in North America and the US, they do have wind profilers, which are land-based profilers, which do sample the atmosphere more frequently than twice a day. Again, somewhat the resolution issue. At least they have a high time resolution. Again, with time resolution too, is this question of where you do the observations. Your radiosondes are typically twice a day. Satellites are when usually the overpass of the satellite is, so they're fairly, again, the sampling rate is fairly low. So these are problems that you have to deal with getting observations, especially over the ocean.
Yeah. Yes, indeed. Okay, so don't go past this one. Great. So these gaps in observations are gonna produce a certain problem, and that is because numerical weather prediction is an initial value problem. And what that means is that the errors that exist in initial conditions are going to be the predominant source of forecast uncertainty. Not only that, but the errors that start out are going to grow over a forecast, and they'll propagate downstream. So errors that exist at one point over the ocean will eventually propagate downstream so they're affecting forecasts over coastlines and over land and et cetera. And so that's all important because global weather is interconnected. So an error in one place is going to result in an error at another place. Did you want to add anything, Jack?
Yeah, plus that's going to affect the quality of the forecast as you go on. Yep.
Right. Yeah, right from the initial point. Yep. Okay, so how we're going to solve this problem? Spire RO in this role can fill a key void. So just to quickly explain what RO is. So the idea is that radio occultation measurements are obtained by analyzing the degree to which GPS signals that are passing through the Earth's atmosphere are bent, when they pass through the atmosphere. Using that information, Spire is able to gather profiles of temperature, humidity, and pressure through a large depth of the atmosphere. Right. So importantly, every day, Spire is collecting 10,000 of these profiles right now. And this results in a homogeneous, unbiased data set that is able to cover the entire planet all the time, which is in contrast to something like the Radiosonde network, which is going to launch twice a day. So that continuous nature of the radio occultation data set is going to be extremely important to covering some of these gaps that we've been talking about. Okay, so here I'm showing two examples of Spire RO profiles at two locations that are quite close to each other and only a few moments apart. So both of these are compared with the GFS model profile in green. And so there's two key things I want to highlight here. First is that these examples illustrate the fine vertical resolution and high quality of Spire's RO observations, and that they extend through a huge depth of the atmosphere. And second, I would like to point out that the GFS model atmosphere at this point is much colder than we've observed in the Spire profiles. And that's through a huge vertical depth, right? And so this error is going to have consequences that extend past just here and will extend down to the surface, where in fact in this location, we noted that there was a sea level pressure error of over 10 millibars. And so for anyone in maritime weather, a error of 10 millibars at the surface is going to produce quite a difference in the wind forecast at that point. Did you want to add anything, Jack?
Yeah, I mean, 10 millibars would be a huge error. Even a couple of millibars would be a large error particularly for winds.
Yeah, exactly. Yep. Right. Okay, so keeping in mind the quality of the observations being collected using RO, here's that same plot that we showed earlier that was depicting the 24 hours of maritime traffic using satellite AIS data. And so overlaid here in yellow are all points during 24 hours where we're collecting RO data. And so you can begin to understand how much of a difference these observations are going to make in a forecast when you add them in. Did you want anything, Jack?
No, I mean, the key thing here too with the ship ones is that it's fairly intermittent. Depends where the ships are, I guess, to some extent, versus the satellite ones where you can get it more continuous throughout the day.
Right. Exactly. Okay, so how is collecting this data exactly going to improve forecasts, or how is it? I just wanted to point out here, the increase in data over the oceans is huge, and that covers a whole lot of the gaps we've talked about so far. But in addition, the Spire RO data here shown on the left, compared to the upper air sites on the right-hand side, are also increasing coverage over continental areas and remote regions as well. And so that's all very important and factors into the forecast accuracy. Okay, so like I've been saying, Spire RO has been able to fill un and underobserved regions where additional observations are going to have a huge impact on the forecast. And so to that point, on the right here are plots of the 500 millibar temperature surface. And so on the left-hand side is the ECMWF analysis at initialization. And then on the right-hand side is the 168-hour forecasts for, starting from the top is the Spire forecast, and then the ECMWF forecast, and then the NOAA operational forecast. And so highlighting, the red circles are all highlighting areas where the Spire forecast is highly accurate to that ECMWF forecast. And this is an important result showing that the positive impacts of Spire RO extend way beyond the surface. Right. So to be fair, that analysis was done internally. So the question is, can that be verified externally? And to that point, shown here on the right is a plot that was created by the ECMWF. And this reflects the impact of and forecast sensitivity to a number of different observation types. And so following the reduction in airline traffic in March, which is shown in the light blue line there, the ECMWF increased the amount of RO that they were assimilating in order to fill that void. And that data signal is shown in the yellow line there. And what I'd like to highlight here is that in this independent analysis, you can clearly see that the RO data provided by Spire had a large additional benefit on their forecast. Sean Healy from the ECMWF, in fact, noted that the addition of Cosmic 2 and Spire RO data decreased forecast error by 13 to 14%. And that conclusion that Spire RO has a positive impact on forecasts is backed up by another independent study that was done by the UK Met Office, where they concluded that assimilating observations from Spire, in addition to the current operational network, had a huge, substantial benefits to their forecast performance. And so these conclusions are, I think, very much in line with what the folks at PredictWind have found when they did their own analysis. And on that note, I'll let Jack take over to review those results in detail.
Okay, thank you. So do I have control or?
Jack, you should have control now.
Not working. Oh,
Yep.
There we go. Ooh, no,
It's a little laggy.
too far. Okay, first of all, where are we? Here. Get this some delay here. Okay, so first of all, I'm going to just briefly introduce what PredictWind is. It's a company that's been set up to provide weather forecasts to the sporting and leisure and maritime community around the world with high quality forecasts. So what the PredictWind does is it runs its own in-house proprietary weather prediction models, but also uses forecasts from available high-quality global models as well as other models that's deemed high quality. And they produce this information into a web app that Nick will talk about later, which allows you to do both looking at the forecast, looking at detailed maps of different variables, do routing, departure planning, and get alerts about different conditions, primarily wind conditions. So that's PredictWind. So the next question is, why does PredictWind partnership with Spire? Well, again, Keenan talked about a little bit about this. To get the best weather forecast, you need basically three factors. One is the best initial conditions, which Keenan talked about with what Spire is doing with the satellite RO. The second one is you want a good numerical model, obviously, that has good dynamics, physics, and numerics. And then also you want high resolution to get more detailed. But with weather forecasting, just because you can never sample the air completely, there is always going to be some errors that crop up in any model. And so no model is going to be perfect all the time. So that's why you need a range of models, or what's called ensemble forecasts. Provide multiple forecasts to provide the end user some idea of what might happen, and then they can make a decision on how the forecast evolves. So the partnership with Spire is, first of all, as Keenan talked about, Spire can generate the best initial conditions because they have these additional radio occultation observations, and I think he's demonstrated that definitely helps give you a better starting point for your forecast. The Spire produces its own forecast based on a well-developed model. They're also one of the higher resolution forecast or finest resolution forecast global predictions available. In addition, of course, from Predict Wind, this ensemble question is the multiple forecasts. We'd like to make sure that the end user has those forecasts. Ooh, somebody's controlling it. Okay, so what do we do? Well, we wanted to assess how well the forecasts are doing. So we want to compare the wind observations from stations and to the forecast for the various models to make sure that we are providing accurate information and to give the end user some guidance on how good the models are. So this study I'm going to talk about is based on the 4 global models that we had available. ECMWF forecast, which is sorry, one of the better or world recognized leaders in forecasting around the world. Spire, their forecast using their model and their new observations. The UK Met Office, and what's commonly used, especially in North America, is the GFS forecast. So all these are provided by Predict Wind in their app. And what I will show is some of the results from analysis. So this study was a study over 4 months of this year, from February through June. We collected all the data from the various forecasts and the observations. The observations were hourly mostly, out to 7 days. The forecasts could be hourly, or some of them were 3 hourly. And we did look at coastal stations over land as well as buoys. I'll just talk about those observations that were over the buoys, and about 166 buoys were evaluated for this study. Is it clean? No. How come I can't go forward? I don't have control anymore. Does somebody else have control?
There you go, Jack. You should have it.
Still not going anywhere. You would have taken and just, oh, there we go.
Yeah, I'll take it if you want. I don't know what happened, sorry.
So what are the results? So here we're comparing the buoy observations against the various forecasts over the open ocean. On the left is the wind speed error, and on the right is the wind direction error. So the measure of error we use here is the mean absolute error. So this is, you take the difference between the forecast and the observation, and you take the absolute value of that, so it's always positive, and then you average it over the day and over the 4 months to get the statistics for each day. So the axis is the forecast day from 1 day out to 7 days, and the vertical axis is the measure of error. The bigger the number, the more error there is. So if you look at wind speed, you can see that typically models on day 1 have errors of 2.5 to 3, growing to day 7 where the errors are up to 4 knots. I'm showing here, which if you want meters per second, it's about 1 meter per second is about 2 knots. So the 4 lines there are the Spires in black, ECMWF in gray, UK Met Office in blue, and GFS in the yellowish color. And you can see that for wind speed, the Spire and ECMWF are very close, with the Spire showing a little bit more improvement, a little less air below ECMWF, which is quite remarkable because, again, ECMWF is one of the world recognized leader in forecasting, global forecasts, and the resolution is very high. So the fact that Spire can actually match and beat ECMWF for wind speed is quite good. And you can see that it actually beats it for all time periods, although very small error differences there. But for wind direction, you can see actually the Spire forecast actually is remarkably better about a couple degrees at least, better than the ECMWF GFS in the UK Met Office. So these results tend to indicate, first of all, that Spire is doing a great job. And I think that's largely to do with, because the air is good at day one, is largely to do with their better observations that they're using and the good model. But also keep in mind that these are average errors over 4 months. So this is sort of the mean statistics. Any given day, any given model may be best. So you still have to be aware that you can't just use Spire. I mean, although I'm sure Spire people would like you to use their forecast, but again, every given day you have to look at a range of forecasts to actually assess what might actually happen. And that's what Predict Wind does. So I will hand it over to Nick then to talk more about what Predict Wind does.
Thanks, Jack. Cool. So yeah, so I'm here to make the weather. Oh, hang on. On my screen, what's happened? What's happened, Emily? I don't want to see that.
Oh,
I've lost the slides. Can you bring those back for me?
Yeah, sorry. I thought you were taking over now. You'll take over after. Sorry, my bad.
That's right. Okay, cool. So yeah, I'll just. I know Jack gave us a bit of an intro. So why do we, you know, why did we look at Spire, and why do we want to, you know, go to all the effort of, you know, doing this validation study and looking at Spire, and why we would put them into our, you know, into what Predict Wind offers. And so what we want to do is we want to make complex weather simple and accessible to anyone. And we take that complex part, and which is probably a little bit of what we've just heard about, and we put that into our front end, which is we try and make this incredibly complex and high level weather, and put that into tools that are usable. Why did we add Inspire? So the reason we did the validation study was to decide whether we were going to add Inspire, and obviously the results showed that that was a good idea. You know, there's lots of weather models out there, and you know, we could add in all sorts of weather models, but we want to add the very best weather data to what we offer our customers, which is why we have ECMWF and now Spire, UKMO, and you know, and the other models that we offer for various different reasons. You know, and especially those three and the GFS at the global level, having those models there, you know, really gives our end users something, you know, that isn't available elsewhere, and really powerful tool, you know, group of weather models to use in our tools. Worth noting, you know, we run our models as well, and for our coastal users, you know, we have them at really high resolution, which is, you know, can pick up a lot of things that global models don't. And so, you know, that's why we have that range and go to the effort and cost of running our own models there as well. So can you just flick to the next slide, please? So what do we have? Yeah, so we how do we you know, display this data in a usable manner? We have two main apps, and so we have on the left-hand side of the screen here, we have what we call the Predict Wind app and website, which is what we'll be looking at in a minute. And so that is for you know, if you can use that from anything. If I want to take my kids down to the park, you know, is it going to rain on me? Or you know, I'm going to go sailing today, you know, at the local yacht club. What's the wind going to be like? What's happening? And I can look at all those models and digest that data, because we're all about giving people the tools to make the decisions. The other side that we'll look at a little bit is that we have this offshore app, So that's for if you are going outside of cell phone range or Wi-Fi. And so that is designed to be used on satellite connections. You get the data in a grid format. So you can, anywhere that you are out in the ocean or anywhere on the planet, you can use that tool, and you can get this, the literally the best weather models in the world, which gives you the ability to make better decisions. So, and also in that tool, which we're going to talk about in the next slide, is weather routing. And so something that we spend a lot of time on and have recently done a big update on is our weather routing tool. This is our optimal weather routing is focused on sailing boats. We do have a power boat, usage in there as well. But in the recreational marine market, we're focused on sailors. So whether they're racing sailors or cruising sailors, and having this tool that considers, I'm not going to go through all of these things, all of these points here, but you can have a look through them yourselves. But there is a lot of information going in there, and a lot of things taken into account for your weather routing. And so it's not just a point and shoot. And with all that, if you can just flick on to the next slide. With all the information in that weather routing, obviously having the very best weather models to fit in with that makes it a more useful tool. So if you just give me control now, Emily, I will go to my screen sharing.
Yeah, and I'd just like to remind everyone attending that if you have any questions, you can use the little question tool that you have on your GoToWebinar control panel, because after Nick's demo, we will take some questions.
Cool.
And while Nick is doing that, I just wanted to point out that looking at that weather routing that Nick was showing there, you could see that that's the different models produce different forecasts, and so each route is a little bit different than each other. So this is a tool that is developed to help the sailor make a decisions of what route is going to be best for them. Yeah.
I've got another weather out there. So everyone can see my my tables there. It looks like we're on there. So yeah, so we have this really high quality group of weather models there, and we've just literally just added Spire in. As I said, it wasn't just let's just add another weather model in. We did that validation so that we knew that was the right decision to make, and obviously Spire proved itself to be worthy in there with beating the ECMWF in an area that really matters to us, which is out at sea. So we have all these tools that allow people to look at the forecasts and analyze them, and as you can see there, that's pretty complex, but I can click over here on the left hand side, and we can put all those forecasts together with a bit of an algorithm. And there's a bunch of tools in here, and wind maps and wave maps and all sorts of things. We have ongoing validation. I know that Spire are continually looking to improve their model, and that'll just only be better for us, and we'll continue to evaluate. We have observations that so you can compare your forecast to the real world observations. And then down here we've got tools, which we'll look at in a second. So just another way of looking at that, as you can see here, we've got a split screen mode. On this left hand side here, I've got the Spire model, and on the right hand side I've got ECMWF, and I can scroll through the week with the graphics, and I can choose different sorts of graphics to look at the weather in different ways. I can look at an isobar map there, and I can up the left hand side here, I can go off the split screen and just look at the the single model there. So yeah, I mean, obviously I could talk about this all day, but we're not here for that. So in the tools here, so the part of why we would have the Spire model is obviously having these top level forecasts, and but using them to make them usable, we need tools. And so here I've run a departure plan, and I can compare. We don't actually have, as I said, we've just added the Spire into our front end, so we don't actually have the Spire running in our weather routing just yet. That's coming shortly. But you can see here I've run a departure plan, and I can compare if I left on different days, what the average wind speeds are, the time I would be reaching, the time I would be spent in different wind speeds and wave heights. So that sort of that's part of what we want to do, is give people these tools. But why we're giving them the tools is that it means that they can be safer, get more enjoyment out of what they're doing. If anyone's done a rough crossing on a yacht, that might be the last one you do. But if you can get your departure time right, and then you can use the tools that we offer while you're at sea with these leading weather models, you can have a better trip and get more enjoyment. But the other side of that as well is safety. I mean, and that's the same whether it's commercial or recreational. Having these really good weather models that are able to get the initial conditions data from places that other models aren't, that Spire's doing, it means that we can get better data and better tools. So you see here, we don't just offer, we're not just looking at atmospheric stuff. This is ocean data. We're looking at the Gulf Stream here, and that's also taken into account in our weather routing. And you can see here the weather router has actually done a pretty nice job of matching up the weather and the currents to best effect. So just flick over here. So this is our weather routing tool, and I have run a weather route here, and this is for the Vendée Globe race, which is on at the moment. So 33 people sailing around the world in 60-foot boats by themselves, racing around the world. And I've run a weather route from where one of the guys is here, and they're trying to get down here. This boundary here is actually an ice gate, and so they want to get down to the bottom of the world as fast as they can. But what we can see here, if I just zoom in and scroll up, is to, within sort of 2 days with the models that we've got here, we've got a reasonable amount of consensus, because you can see that our weather routes are going the same way. And then after that, obviously, they split apart. There's uncertainty in the models. And so this is why we want to have, Spire in there, because in this part of the world, in this part of the ocean, they've got more data feeding into their model than anyone else. So possibly you can make better decisions. You could rely on the Spire model more, but also it gives us more consensus to look at. Would that be lining up with the ECMWF, or would it be lining up with the GFS, or when we have it in there as well, the UKMO? So yeah, really important to have not just any data, but the best data in there, so that you can make the right decisions. And so, as we can see, the fastest way from A to B isn't a straight line, and understanding the movements of the weather systems is what makes the tool useful. I can scroll that through and see these guys. I mean, they're a little bit mad. Do admire them. So yeah. Anyway, I won't talk any longer about that, but if you do want to know more about what Predict Wind does, please reach out to our support team. They're a great group of people, and we'll be able to help you with any questions you have. And we have a lot of information on how you use all these tools and how you can get the best out of these forecasts, and more information on the full validation study that we did with Spire is on our website, so you can find that there as well. So that's pretty much me, Emily, if you want to take back the reins.
Thank you very much for that. Okay, so just before we launch into the Q&A, and we have had some questions, so thank you to everyone for your questions. There we go. I'd like to launch one final poll, so just give me a second. There we go. So do you think you can leverage Spire's weather forecast in your business or activity? And yeah, there's still time to get your questions in if you want to get them in while I'm running the poll. And everyone will receive a recording and contact details for both Predict Wind and Spire in the follow-up email. So yeah, if you have any further questions or you want more information, someone from Predict Wind or Spire respectively will be able to reach out to you and help you out. I'm just going to wait a little bit longer because people are still voting. Okay, I think that's good. We will close the poll now. As I said, feel free to reach out to us if you have any other questions or want more information. So for the Q&A, I'm going to kick things off. This one's for Keenan. So due to the scarcity of ocean observations, what would you say the value of ocean observations are if they could be collected at a higher density or frequency?
Yeah, that's a great question. So the frequency is super important, and it's something that, like, I think we get at with the Spire RO observations. Like, it's a key point why the buoy observations are super important, is they're continuous at the surface, right? And so, like, you get these ship observations, but like Jack pointed out, they're pretty sparse in time, and they're gonna have that. So that frequency thing is hugely important. I think that's like something that's big about the Spire RO, is we have this continuous data set, even if they're not all in the same spot. So increasing the frequency is huge. In terms of the density, I mean, that's kind of goes right to my point, which is that the more observations you can get on the ocean, in the vertical and on the surface, is always going to improve your forecast because of how many gaps in observations there are over the oceans. Hope that answers the question.
Great, thank you. So the second one is also for you. So, but Jack, feel free to jump in if you have an opinion. And so, what is the general impact of ocean surface observations on weather forecasts?
Yeah, so I mean, it kind of goes to the same point that the general impact of ocean surface observations is going to be based on them filling those gaps in what we currently are observing. I'm curious to hear what Jack has to add to that, though.
I mean, I guess I'm not quite sure what the question is saying. What was the question again?
The general impact of ocean surface observations on weather forecasts?
I mean, the way the models work with forecasts is that they use the available observations to initialize the model, and then the model makes a forecast. And if you don't have observations, basically the models use the previous forecast as the best guess of what the actual conditions are. So the more observations you have, the better you'll constrain that initial state. And if you don't, then the model can potentially have greater error because doesn't have anything to constrain it to what actually is happening out there. So obviously, the more observations you have of the ocean winds and currents, and the better off you are going to be able to see what's going to be in your forecast, because you start off with the better conditions.
Next question, sorry, I actually skipped one. Is Spire using its own model or feeding better observations into one or multiple existing models?
Yeah, so Spire is running its own model, and we are constantly developing both the data assimilation system that assimilates these RO observations, as well as the dynamical core of that. I mean, the model itself in Spire's. Yeah, so the answer is basically yes, of course. But yep.
Okay, cool. Right, so I'll move on to the questions that are for Predict Wind. Will Predict Wind make the Spire model output available in GRIB format in their subscriptions?
Yep. Yes, it is. It will be in GRIB format, and yeah, that's weeks away. Not much further. So obviously, integrating a new model in is a big amount of work, and so at the moment we're putting it all into the Predict Wind app and the website, and then we roll it all into the offshore app.
Okay. Have you compared the percentage of accuracy for each model in each ocean? Is there a difference? I guess that's for you, Jack.
Yeah, I'm in the process of doing that. It was a lot of data and lots of stations to compare, and I'm in the process of trying to evaluate where the best benefit is of what ocean basin, and so that is something that will be coming, but I don't have the answer right now.
Okay, thank you very much. Is Spire going to be available in all kinds of subscriptions? I guess that's unique.
Yes, it is actually. So in our free version, you can have the wind maps and basically the same as we treat it the same as what the ECMWF data is. So obviously Spire is a paid data source, which most of the sources that we have are, and so but we do have that to a certain degree, a bunch of things that you can use in the free version. So, and then yeah, different functionalities do go into our paid services, and yeah.
Okay, cool. All right, well, I think that's the last of the questions, actually.
Cool.
Checking. Yeah, I think that's it. So thank you very much, everyone. And yeah, well, like I said, we will send over the recording in an email, as well as a few other collaterals that you could find interesting. And we'll make sure that both Predict Wind and us are easy for you to contact. And we'll also have a little offer in our email for those of you who answered that you were interested in finding out about Spire Weather. So yeah, thank you, Jack. Thank you, Nick. Thank you, Keenan. And thank you to everyone who attended. Have a great day or evening wherever you are in the world.
Thank you.
Bye.
Bye.
Bye.